Okay, picture this. Something deeply, fundamentally, your DNA becoming a target, not, your bank account, but your actual genetic code.
It sounds like something straight out of science fiction, doesn't it?
It really does. And today we're diving into something that's, rapidly becoming reality. The growing threat of cyber attacks targeting next-generation DNA sequencing.
NGS.
Exactly, NGS. And what's really startling here is this collision. You've got genomics, this incredible field unlocking life's secret, crashing into cybersecurity. And a recent study, University of Portsmouth, just came out April 23rd, 2025. It really shines a harsh light on this. It shows just how vulnerable these powerful DNA sequencing tools are becoming.
Tools that were supposed to be revolutionary for healthcare, yeah.
Absolutely revolutionary. I mean, NGS is what makes personalized medicine possible, treatments designed just for your genes.
Right, and cancer diagnosis. It's making that much earlier, much more precise.
And tracking infectious diseases like we saw recently. Plus all the genetic research it fuels. It's immense. But now this amazing technology, this power for good, is facing a really serious, honestly quite terrifying security risk.
Yeah.
So you listening might be thinking, okay, DNA hacking, what's that got to do with me? And that's exactly what we're digging into. The, frankly, shocking ways your most personal information could actually be at risk.
So let's just get right into it. Why? Why would hackers even want DNA data?
Good question.
Well, it boils down to what it contains. It's incredibly personal biological information, your predispositions to diseases, your ancestry, even things about your physical traits. It's all in there.
Wow. So it's valuable.
Hugely valuable. Not just for research, obviously, but for, let's say, less ethical purposes, too. And another big factor, how accessible a lot of this data actually is.
What do you mean accessible?
Well, in the name of science, collaboration. Huge DNA data sets often get posted online.
Really?
Yeah. And while that openness is great for speeding up discovery, it unintentionally creates these huge vulnerabilities.
That's quite an irony, isn't it? The drive to share and learn creates a backdoor for criminals. Okay, let's get specific then. What are the really creepy possibilities here? I mean, I read about synthetic DNA-encoded malware. That sounds completely nuts. Is that actually a thing?
It sounds like it, but it's not just Hollywood anymore. Back in 2017, University of Washington researchers, they actually proved this concept. It's terrifyingly real.
How does that even work?
So they managed to embed malicious software code into strands of synthetic DNA.
No way.
Yes. And the implications are just staggering. When that tampered DNA gets sequenced, the machine reading the code, it could mistake the malware DNA for computer instructions.
And then execute them.
Potentially, yeah. Execute harmful commands right there in the lab system, maybe corrupt data, maybe even spread to other connected networks. Think about it, your biology becoming like a cyber weapon.
That's more than unsettling. It feels like a violation on a whole different level. What else? What other sort of nightmare scenarios are we looking at?
Well, another big concern is AI. Artificial intelligence manipulating genome data.
Okay.
AI is brilliant at finding patterns, right? And generating realistic data. So imagine using AI algorithms to subtly tweak your digital genetic code, inserting false information, maybe hiding real disease risks, making changes so small they're almost impossible to spot.
And the impact of that could be
devastating. For medical diagnoses, for personalized treatments, it could completely undermine genetic research if the data isn't trustworthy. A tiny edit could lead to a totally wrong understanding of your health.
So they could steal it and they could corrupt it.
Yeah.
With potentially life or death consequences. That's a serious escalation.
Exactly. And then there's this whole issue of anonymized data. We think it's safe because names are removed, but
that's not really anonymous.
Increasingly, no. Cybercriminals are getting really good at re-identification. They take this supposedly anonymous genetic data and cross-reference it with other stuff out there, public records, social media, you name it, or they use clever algorithms. And boom, they can often link that anonymous DNA back to you, revealing your entire health profile, family history, everything.
Wow. Is there data on how easy that is?
Yeah, a 2019 study basically said that 99.98% of Americans could potentially be re-identified using just 15 common demographic details.
99.98%. So anonymity is pretty much an illusion in these big data sets.
It's certainly becoming one. It's a massive challenge.
Okay, so the motives there, the methods are getting scarily sophisticated. Is this mostly a future worry, or is the healthcare system where all this data lives already being hit hard?
Oh, it's already under siege. The U.S. healthcare sector, it's relentless. Look at 2024. The stats are just stark 734 major healthcare data breaches.
734. And how many people affected?
Get this, 276 million individuals.
276 million.
Yes. And that's a 64.1% increase from 2023.
That's unbelievable growth.
And the biggest single healthcare breach ever, also 2024, Change Healthcare. It's estimated 190 million people affected.
Good grief. These aren't just small leaks then. This is massive compromise.
Absolutely massive. And the cost, it's huge. Financially, the average healthcare data breach in 2024 cost about $408 per record. That's way higher than other industries.
And the total cost per breach?
On average, a staggering $9.8 million.
Wow.
And guess what's driving a lot of the record compromises? Ransomware. It was only 11% of the number of breaches, but responsible for a horrifying 69% of all compromised patient records in healthcare last year.
69%. So ransomware is basically crippling these systems and stealing the data. We hear about hospitals being locked down.
Exactly. It shuts down essential services, puts lives at risk. And now we're talking about adding our most fundamental biological code, our DNA, into this already incredibly fragile environment.
And why is there so much DNA data being collected anyway? What's driving that?
It's the genetic testing market. It's just exploded.
Ah, those direct-to-consumer kits.
That's a big part of it, yeah. The whole U.S. market was worth $5.3 billion in 2024, projected to hit $14.4 billion by 2033.
$14 billion.
And that direct-to-consumer part alone, expected to reach over $7 billion by 2030.
So more tests, more companies, more data.
Exactly. An unprecedented amount of super sensitive genetic information being gathered and stored, often by many different companies.
Sure.
It just makes it a bigger, juicier target for criminals. More data, more places, more risk.
It really feels like a perfect storm brewing. Sensitive data, easy online access sometimes, a healthcare system getting hammered, and this booming market. It's hard not to feel, well, deeply uneasy. Can we compare this DNA threat to past cyber attacks? Does that help understand the scale?
Oh, absolutely. Think about the big ones. Equifax, Yahoo, Change Healthcare recently.
Yeah.
They exposed data for hundreds of millions. Identity theft, financial chaos.
Right.
Huge impact.
But like you said earlier, DNA is different. It's fundamental. You can cancel a credit card, right? You can't just cancel your DNA.
No, it's immutable.
Exactly. Immutable. That raises the stakes dramatically. And think about attacks on critical infrastructure. Stuxnet, Colonial Pipeline.
Yeah, those showed cyberattacks can have real-world physical consequences. Precisely. And DNA hacking. It could potentially lead to similarly profound, devastating outcomes. Not just privacy, but maybe messing with scientific research integrity, maybe even national security down the line.
That really puts it in perspective. It's
Right.
way beyond just privacy. You mentioned some mind-blowing facts before. Can you hit us with a couple that really drive home how shocking this vulnerability is?
Okay, well, consider this. We all share 99.9% of our DNA. It's that tiny 0.1% that makes us unique. But even in that tiny fraction, there's an immense amount of deeply personal info. Your whole genome is about 3 billion DNA-based pairs. Think about that number. 3 billion bits of highly specific biological data.
It's almost impossible to comprehend.
Right. Now, here's a statistic that should really worry people. That 23andMe breach in 2023 compromised data for 6.9 million users.
Nearly 7 million.
And here's the kicker, the truly shocking part. Some estimates suggest your genetic data could be worth up to 50 times more than your financial info on the dark web.
50 times, 50. Why? What makes it that valuable to criminals?
Well, it's that unique combination, isn't it? It's permanent, unlike a credit card number, and it reveals so much. Your ancestry, your health history, future disease risks, even info about your relatives, biological relatives.
Okay, I see.
So think about the potential for highly targeted scams or discrimination by insurers or employers if they could get their hands on it, or even potentially crafting biological attacks in the future.
Yeah.
The long-term implications are really quite concerning.
We talked about that chilling 2017 DNA malware experiment. Were there other sort of real-world examples or expert warnings that really jumped out from the Portsmouth study or related work?
Yeah, definitely. One recurring theme is just how easily this supposedly anonymized data can be re-identified. That comes up again and again in different studies. It's a huge red flag. And researchers like Dr. Nazreen Anjem at Portsmouth, she's the lead author on that new study, they're urgently calling for a total paradigm shift in how we secure genomic data.
A paradigm shift. What does that mean practically?
It means basic stuff like encryption isn't enough anymore, not against these sophisticated threats. Dr. Maureen Hassan, another researcher, really emphasized how personal this is. A breach of genomic data is just profoundly different, more lasting than other data theft.
Right.
Even the Presidential Commission on Bioethical Issues stressed we need tight control over access and use. Just trying to strip off names isn't cutting it.
And that 23andMe breach, it feels like the perfect horrifying example of these fears becoming real, right? Can you unpack that a bit more? How bad was it?
It was bad, really bad. 6.9 million users affected in 2023. And it wasn't just names and emails. Hackers got detailed ancestry info and, crucially, sensitive health details derived right from their genes.
Wow. Health details, too.
Yes. And what made it especially alarming was the targeting. Data specifically for people with Ashkenazi Jewish and Chinese heritage was put up for sale online.
That suggests like a hate motive or something targeted.
It certainly suggests a deliberate and potentially discriminatory motive.
Yeah.
But then the story gets even more shocking. 2025. 23andMe filed for bankruptcy.
They went bankrupt after the breach.
Yes. And now nobody knows what happens to the genetic data of their 15 million customers. Is it an asset in the bankruptcy? Could it be sold off? Maybe to a company with much weaker privacy rules?
Oh my God, your DNA treated like office furniture in a bankruptcy sale.
That's the terrifying possibility, yes. The uncertainty is huge and deeply troubling for anyone who's ever used these services.
That is absolutely chilling. So what can actually be done? Is there any hope? How do we protect this incredibly sensitive data?
Well, the Portsmouth study is pretty clear. This needs a massive coordinated effort. It's not something one company or even one sector can fix alone.
So who needs to be involved?
Governments need to step up with strong, clear regulations and actually enforce them. Regulatory bodies need specific, tough guidelines for genomic data security and privacy. Funding agencies, they need to pour money into research on cyber-biosecurity. And, really importantly, we need way more collaboration. Computer scientists, bioinformaticians, biotech people, security experts, they all need to be working together much more closely than they are now.
Breaking down those silos, are there specific technologies that look promising?
Yeah, there are. Things like developing new sequencing methods that have security built in from the ground up. That's one area.
Okay.
Also, much stronger, multi-layered encryption is absolutely essential for data on the move, data at rest, all of it. And AI could actually help here too.
How? Using AI for defense.
Exactly. Using AI-powered systems to constantly watch genomic data sets for anything weird, any anomalies, to try and catch attacks in real time or even prevent them.
Okay, that makes sense. What about us, the individual listener? What can we do to protect our own genetic information in this, frankly, risky landscape?
That's a crucial question. We need to be much more aware, much more cautious. Read the privacy policies. I mean, really read them.
Yeah, the small print nobody reads.
Exactly. Understand what data they're collecting, how they'll use it, who they might share it with. Ask yourself, are you truly comfortable with that? Don't just click agree. And don't be afraid to opt out of data sharing if you're not comfortable. And here's something else for people who've already done these tests. Consider asking the company to delete your data entirely.
Is that usually an option?
It often is, but you might have to dig for it.
Yeah.
But it's about asserting control.
Right.
Over your own fundamental biological code.
So we come back to that first question. Is your DNA safe? And the answer seems to be, well, a very worrying, not really, or at least not yet.
I think that's a fair, if sobering, assessment. The potential of genomics is just immense. Truly transformative for medicine, for understanding life. But these cyber threats, they're real, they're growing fast, and they need our urgent, focused attention right now.
It really forces you to think differently, doesn't it, about what counts as sensitive information. We worry so much about bank details, passwords. Maybe it's time we started treating our genetic code with that same level of caution.
That's a really powerful point.
Because as we've heard today, it might just become equally valuable and maybe even more vulnerable in the near future.
Absolutely. And it highlights that this field, cyber-biosecurity, it's not standing still. It's evolving incredibly quickly. Staying informed about these unprecedented threats and the potential solutions is going to be vital for all of us navigating what comes next.